Okay, everybody. I think we'll make a start, actually, because we're back 6:05, and we need to make a quick exit for the conference dinner at 7. So what I'm going to do is now start the recording. Just to let you know, we're going to record this so we can share it online later. Okay, well, welcome, everybody. I realize it's been a long day, but this should hopefully be something quite different, and you've all had a refreshment. At least those here have. I hope those at home or watching remotely have also managed to grab a refreshment. This is welcome to the Barrie Jones Memorial Award Lecture. So this award was set up as a kind of collaboration between the Astrobiology Society of Britain, which there are various banners for out there, ASB, and the Open University, to honour an individual who has made an exceptional contribution to the community, this planetary and astrobiology community in the UK, via education and outreach and public engagement activities. So Barrie Jones, who the award is in honour of, he was a much loved member of the Open University community and the space science community in the UK generally, and a passionate educator and communicator of science. So you'll hear a little bit more about Barrie in a minute, because I'm going to play a video that's been pre-recorded for us by his son, Iago Elkin Jones. And originally, the plan was for us all to be here together and to present the award to our winner in person, obviously. But various things, as we're all kind of used to now over the last couple of years, have conspired to make that not happen. But we're really glad that because we've all kind of adapted to this new environment of hybrid meetings, that we can actually bring you this award lecture remotely. So I think I'll start now by playing a little video now from Iago. Just give me a second while I share that. Actually, before I do that, what I'm going to do is actually introduce our winner. The winner of this year's Barrie Jones Award is Áine O'Brien. Áine's online as well, so you will be able to see her in a minute when she gives her talk. In fact, what I'll do is I'll stop presenting, and Áine, do you want to turn your camera on? There she is, everyone. Round of applause. So Áine is a PhD student at the University of Glasgow, studying organic compounds in meteorites, and is also a former high school physics teacher, and was the former diversity officer at the Royal Astronomical Society. So Áine was the co-creator of Roving with Rosalind, who some of you may well have heard of. It's an outreach program designed to engage and upskill underserved audiences within STEM through doing kind of mission-based activities. So Roving with Rosalind taught over 5,000 children so far across the UK, and is actually being used as a framework of a Europe-wide robotics outreach program with ESA. So as well as that, Áine has delivered high-quality space education and training to schools and organisations in low-income areas and to patients at children's hospitals. She's also a tireless advocate for marginalised communities within STEM. And promoting and driving change in the planetary community. So as well as these activities, Áine has also been heavily involved in the retrieval and study of the Winchcombe meteorite, which we've been hearing a lot about today, and has kind of presented and communicated with the public through TV, radio interviews on the BBC, Reuters, articles in magazines, podcasts and conferences, classroom events, museums, etc., etc. And she actually gave the February 2022 Royal Astronomical Society lecture on the Winchcombe meteorite, and helps the public identifying meteorites and meteorongs, and has written 2 popular science articles about the stone's retrieval. So now I will play a little video message from Iago Elkin Jones. Okay, here we go. Take it away, Iago.
Hello, my name is Iago Elkin Jones, and I'm the eldest son of Barrie Jones, whose award is the reason we are here today. I'm sorry that I cannot be with you in person today. However, it is still a pleasure to be part of the annual lecture given in the name of my father, the late Professor Barrie Jones. And it is an honour to present this award to you, Dr. O'Brien. I know that my father would have approved of you as the recipient for the 2022 award, an award that celebrates astronomical work in general and broadening participation in particular. Astronomy was my father's lifelong passion. Passion is a rather overused word these days, but in my father's case, it was most certainly true, as I myself was to learn very early in my life. My father's first introduction to astronomy was in the early 1950s at Miriam, the Welsh Calvinistic Methodist chapel that his own father was devoted to. For the lecture, given by a TOC 8 member, a club formed in 1915 to support ex-soldiers, made a big impression on him. Only weeks after it, he was grinding the first of his own many mirrors to make the first of his own many telescopes. And thus a passion and a career was born. My father's research career was varied. It encompassed gamma rays, architecture and acoustics, seismic signals on the moon, and solar energy storage on the Earth. In the late 1990s, he became interested in exoplanets at a time when only 5 or 6 had been discovered, and each new discovery was a cause for celebration, and a fine Welsh whisky too. His career pulled the whole family into his orbit. In 1982, when I was 13, he cut a hole in the roof of our house and built an observatory, complete with purchased telescope this time, charts, tables and cameras. I have a fond memory from a winter's night observing the full moon and capturing an aircraft pass across the field of vision. Another is of him lecturing my primary school about the size of the solar system with nothing more fancy than ping pong balls and oranges to show the relative distance of all the heavenly spheres. Writing and teaching were indivisible parts of his passion. They manifested themselves in so very many different ways and in so very many different places. Consider the excellent course materials he wrote, the summer schools he helped to organise, his commitment to the public education of science through the Society for Popular Astronomy, and the very many extramural lectures he gave, the most memorable one for me being the one he gave under a dark night sky deep in the Botswanan bush. With people from different backgrounds and with different levels of education, he shared his passion. So it is deeply fitting that this year's award is given to someone with an impressive early trajectory in astronomy outreach, to someone who inspires through herd broadcasting, and to someone who shares my father's fascination with Mars and all things Martian. So, from one current English school teacher to an ex-physics school teacher, Dr. O'Brien, thank you for accepting the Barrie Jones Memorial Award for 2022.
Okay, well, thank you from remotely to Iago for that lovely introduction. And now it's my pleasure to hand over to our award winner, Áine O'Brien, who will be telling us a little detective story, I think. So Áine, take it away.
Hi everyone, and thank you so much for that amazing introduction. Thank you so much for the award. I can only hope that I do Barrie justice today. Fingers crossed I do. As you've heard, he had a very wide-ranging research background. Hopefully what you'll hear is a very wide-ranging story of this little thing that I ended up accidentally doing during lockdown. Colleagues at the OU and NHM, you've heard bits of this, but I've done a bit more deep diving since. What's exciting is it's part of a paper that we've just had accepted, so I can tell you as much more about it than I might have been able to say to those of you who I have told bits of this to in the past. So I'm just gonna do the whole screen sharing malarkey and we'll see how we get on. And I'm really sorry I couldn't make it, like I'm sure many people who are involved in this, train strikes let me down, but I'm so glad. The hybrid world is so snazzy. What an amazing conference setup you folks have had. So without further ado, welcome to CSI Lafayette. I don't have any sunglasses to pick up off my head, but here's one version of my first slide, or indeed here is a much more fun version of my first slide. yeah, my friend had a bit of fun. I just asked him to make a logo for me and he came back with this. So it's pretty cool. Anyway, so here we go. What's the start of our story? Well, for the benefit of probably not people in the audience, but this is going online afterwards. So anyone could end up watching this, probably just my mum. Life as we know it is based on the molecule or molecules based on carbon. So that's everything from DNA, like you've got whizzing around as a GIF in front of you, to your cells, all sorts of things. Everything we know on this whole planet is based on this carbon-based compounds. So it sort of stands to reason that if you're searching for life on Mars, you're kind of going to look for organic carbon-based compounds. And this stretches right back to the Viking missions of the sort of 70s, which was, you know, pretty long time ago, really. So the sort of main aim of these Viking missions, very first landers on Mars, was to search for signs of life. And they used GCMS, which is one technique you can do, very similar, in fact, to what our whole detective story is about today, to look for organic compounds. Fast forward to the sort of missions going on just now. We've got Perseverance, which is part of the current, you know, one of the NASA missions. Again, the audience probably all knows this. What I love about Perseverance and what is most relevant to our talk today is we've got the Sherlock instrument, which searches, it's called scanning environments for, long words, but basically it looks for organics on Mars. And I just love it because it's obviously called Sherlock and this is a detective story. And even more relevant still is on board Sherlock is actually a Martian meteorite. And today's story is all about Martian meteorites. Our lovely little rover brought a piece of Mars back home. Not the one that we're talking about today, but still really lovely nonetheless. And in terms of successes that we've had in this sphere of looking for organics, well, Curiosity has had quite a few. One thing that was really cool that it found out, particularly so, is evidence for annual methane variation on Mars, which is really interesting because this stuff hangs around for about 300 years. So it should be stable for that amount of time. So to see it seasonally means something is going on to form it and change it in that amount of time. And also in 2018, Eigenbroder et al. Found evidence for the presence of sulfur-bearing organic compounds, what we call thiothenes, on Mars. So these are just in the surface, basically, of the soil that Curiosity found. A bit of a game changer there. And as you'll see in a minute, really quite relevant to the work that I've done. So for those in the audience who don't know, or probably maybe watching this, don't know about Martian meteorites, these are basically bits of Mars that have been smashed off the surface from an impact, flying around in space for a bit and land on Earth. And my PhD has been focused all about the organic compounds that we see in Martian meteorites that are really quite basically the same as what we see, what our Curiosity mission and what Perseverance is kind of finding on Mars just now. And what these things look like is this kind of sort of dark blobs hosted inside, I'm being really technical here, dark blobs hosted inside igneous minerals. And you kind of get this, and that's like an oxide, and you get this sort of kind of an envelope of organic material sort of enveloping them. And my PhD is basically trying to work out, which I've just submitted my thesis for 3 weeks ago, so I'm not quite a doctor yet, but Richard Iowadi did call me Dr. O'Brien on Have I Got News for You a few weeks ago. I think Ashley mentioned that earlier, that with Fireball Alliance ended up on telly. And he, you know, if Richard Iowadi gave me a PhD, that's close enough as far as I'm concerned. Anyway, I digress. So basically, I've been trying to work out what do these organics look like in our Martian meteorites? Where might they have come from? And just kind of what's the sort of context of them. And one of the techniques I've been using to do that is kind of looking at the overall bulk content. So taking a bit of Mars, crushing it, dissolving it, and putting it in a fancy type of mass spectrometer, and kind of just seeing all the organic molecules that are in there. And it's a technique that's called metabolomics. So it's actually from a kind of biochemistry team. So that's what's been really fun about this. One of the many elements of this work that is very cross-disciplinary, as you'll see in a minute, ended up in all sorts of worlds. So this is probably the most technical part of today's talk, or one of the most technical parts, I suppose. But basically, metabolomics just means looking for compounds that kind of represent different reactions. Basically, when you have biochemical pathways or any kind of reaction that life does, kind of little compounds are produced as a result. So, and this technique, this LCMS metabolomics, is so sensitive that it could detect paracetamol in a drop of blood. So pretty wild, really. And it's really handy technique for just what kind of organics have we got in there. And the way you can do it is you can either do it as a kind of targeted thing or a non-targeted thing. And the way I mean by that is if you've got a sample and you know there are certain types of compounds, like different functional groups for those of us who kind of got that chemistry background, but basically different shapes of your organic molecules. If you know what kind of compounds you're looking for, you can use standards or even amplify your sample specifically using a thing called derivatization. And that makes it targeted. That's saying I'm going to look for maybe just amino acids, for example. Or if you don't really know what you're looking for, you can do it as a non-targeted thing, which basically you're dissolving a wide range of stuff and you just kind of see what you're getting there. And that is what I did. So what I did was dissolved the organic content in 2 Martian meteorites. One was called Lafayette, one was called Narkle. Then I also looked at some analogues of Martian samples as well, and a bunch of like blanks, like of just what was going on in the when we were in the laboratory. So what this is this scary looking thing. Hopefully it won't be very scary in a minute. It's just a heat map that shows the different intensity of a whole load of different molecules we detected in every sample. Each tiny row, and don't worry, you're not meant to see them really, represents one organic compound that was detected in something that in one of the samples at least. The thing isn't arranged in any particular mass order. It's literally arranged by like similarity. So you basically, if it's bright red, it means there's loads of that compound in there. And if it's bright blue, there's like none of it. So what have we got in here? Well, just to say this blank that looks really different, that's the methanol only blank. We use 3 different solvents. Methanol's a really like polar solvent. So it's going to dissolve really strongly one kind of thing, which is why it stands out. It's not just weirdly contaminating. And this thing here is JSC Mars 1. It's a NASA simulant of Martian regolith from Hawaii. This is the Lafayette meteorite. So what you're seeing here is a bunch of organic compounds in Lafayette that stand out that were not in any of our other samples. This here is the Narkle meteorite. This is the same type of meteorite as Lafayette. So for those of you who aren't meteoriticists, Martian meteorites have 3 main types. You've got narcolites, shergottites, and chastagnites. And narcolites all kind of came from the same sort of volcanic flow, lava flow. People argue a bit. Well, same sort of volcano on Mars. And so Narkle and Lafayette are from the same little bit. And then I've got my 2 analogues from Svalbard, which is an island up in the Arctic. And we use these because these have similar formations, organic formations in their igneous rocks that really look similar to ones you see in Martian meteorites. So this is just basically the overview of my results. One way of showing it. Another way is a thing called principal component analysis. I promise it gets more exciting than this. It isn't all just maths and graphs, okay? Just needed to show you this to kind of show that the experiment was legit, I promise. It does get cool in a minute. So what this is just a statistical way of showing how different all your samples were in your experiment. So this is just all the pooled aliquots to show that basically every time we ran on the LCMS machine, it was consistent, but that's a good thing. They're all kind of the same. And here's all our Narkle samples, showing that they're clustering together, but apart from everything else. Here's our Lafayette samples. So these are all the organic compounds in there, like a way of representing that, showing quite distinct to the Narkle ones. And here's everything else clustering together, all our blanks, all our analogues, all our simulants, all having a really similar metabolic distribution. This is made in this R-based software called MetaboAnalyst, and it's really useful because the other way of looking at the data is a massive spreadsheet that looks like this down for ages, basically, and you basically get this. There's like 7 different tabs, and this is what pops out, and so you can see one graph is a lot easier than that. So in terms of what did we actually find, there's a few compounds of interest, and this is where in a second it gets a lot more fun. So one of the things we found was a thing called pentane or pentanous sulfonate. Don't worry if you can't see this, but trust me, right there is a bright yellow peak, and that corresponds to the Lafayette sample. Or in another way of showing it, here is just the intensity of that peak and all the other samples. And you can see a massive amount of it there for Lafayette, and maybe a little bit in Narkler as well. These bits we think are pretty much negligible because there's just noise down there. And this thing is a sulfonated organic compound, sulfur-bearing kind of thing. And what's really cool about that is that's in our Martian sample, and it's similar to what Curiosity has found. So, you know, we're finding some things that match up here. Okay, here's the fun bit I promised about. So one of the compounds we found, basically, this was April 2020. I was just literally scrolling through this massive spreadsheet. It has like, I think we found, I don't know, 900 compounds, something like that, between all our samples. And I was just scrolling through it. They all have really long names. And I'm an astrophysicist by background, done an organic geochemistry PhD. But I mean, still, I'm not a biochemist, right? I was just scrolling through the names, peak lockdown, April 2020. Who even knows what was going through my head at the time? And I was at this particular section of the spreadsheet, and I saw a word that said vomitoxin. And I just thought, what? Like, what on earth is that? Why is there something called vomit in my data set? So I thought I'd have a look at the graphs, like check this thing is real. And yes, there is a massive great peak. Again, you might not see that because it comes out yellow for some annoying reason. But there is a big peak there, and it's definitely only in my Lafayette samples, and it's in all three. And this is what this thing looks like, this vomitoxin molecule. So I just thought, I'm just going to look up, just going to Google it, see what it is. And this thing is a toxin that is produced by a crop disease. And it's called Fusarium head blight. It's a fungal disease that you get on wheat, corn, that kind of thing, but mostly wheat. And what it does is it causes pigs to vomit when they eat it. So I know what you're thinking, vomiting pigs on Mars, right? That's pretty much, right, done, jobs are good and we can all leave, yeah? I mean, maybe. But what I then thought was, let's go for the slightly more possible, likely reason that there might not be swine kicking around, or Peppa Pig isn't probably on Mars. And I thought, well, I might just look into how do you get this disease. I've got to tell you, I was looking for any excuse in April 2020 not to look at COVID graphs. So wanted to find some other stuff to do instead. So I went and looked up this disease and what the ideal conditions were to make it kind of happen. Basically, you need to have a really wet and warm springtime to do with things about the farmland that was in terms of how the wheat is farmed. And we found that it's most likely to happen if you plant wheat after wheat has been there the year before, or corn, or not, rather than a year that they've had none. So this thing is studied quite a lot. And then as a result, I sort of accidentally became a kind of planetary, environmental, agricultural cold case detective, I think is probably the best way to describe this. Because I basically told my supervisors one day, I was like, oh, I found this thing. And I looked at the conditions and here they are. And that was it. I didn't think anything of it. But then my supervisors told me this, which is that the meteorite that we found it in is basically, we don't really know its history, or it's really quite unconfirmed. So this is the earliest record that we have. This is from 1934, from a bloke called Ninja, and basically he says that another bloke called Farrington in 1931 found the meteorite in a drawer at Purdue University in Indiana. And at that point, they basically mistaken it for because if you see, it's beautiful. It's got these lovely lines from the atmospheric re-entry. The meteorite's burned up and it's just gorgeous. Sorry, I know you all understand, getting excited about a rock. So basically, they thought those lines on it were actually like striations, or posh word for scratches, from a glacier. And so they put it in a drawer at Purdue with all these glacial samples. And this bloke called Farrington in 1931 found it in a drawer and thought, wow, actually, that's a meteorite. But they, at that point, didn't really, that was it. They didn't know who had found, they don't really have a confirmed story. What they had is that a student a few years earlier had handed it in to the university while it fell in a pond that he was fishing in, and in the mud next to where he was fishing, and he gave it to the university because he thought it was cool and interesting. And the university said, "Oh, it's not anything interesting. It's just a bit of glacial stuff." So they put it in a drawer. He was supposedly fishing in this place called Tippecanoe County, which is where the town of Lafayette is, where the university is. For some context, Tippecanoe County is in Indiana, and that's sort of in Midwest USA. And my supervisors basically said to me, "Áine, why don't you look up and see if those conditions, if there's any records of the weather in that time in America, in Indiana, basically." And that kind of set me off on this mad wild goose chase, because it turns out do they not just have the weather records? This disease that causes vomitoxin is called Fusarium head blight, and it's such a big problem in Indiana. They have an entire agricultural disease center dedicated to this. This is a publication that they've produced for farmers in the area all about the disease, because this thing is such a big problem. So very quickly I realized, okay, what if there's actually records of the disease? Because if this thing is such a big problem, it kills pigs really quickly, and this Indiana is a massively agricultural state, especially in the 1920s and 1930s, in the early 20th century, it was really dominating that area of America. So I did some more deep diving, and it turned out there's literally a thing called Indiana plant diseases dating back a really long time. And in 1919, so about 12 years before this thing was identified as a meteorite, this disease was rampant. It was all over the state. So it caused 74% of the fields that were examined were infected. It was called scab at the time. It's wheat head scab, Fusarium head blight, has loads of names. And it caused a 50% loss in their infected fields. So it's it doesn't just, mean that pigs throw up. It also really damages your crops as well. So just a quick content warning here. There is an element of historic racism in this, and that it has made this much more interesting, and it gives it extra context. But I do have to say, just wanted to let you know, it's quite an uncomfortable element to this. So in the publication of the story, and what made this really helpful is that, not helpful, but what might help in sort of narrowing down of what's gone on here is that the record of this student was that he was a coloured student of the university. Now, that's what the exact wording in the paper, obviously that would not be my own wording, but in that article, that was how it described. And I thought, well, I found one little article that said there was loads of disease that year. Maybe I can see if there's other years when it was as well. And wonder if there's actually records of how many black students there were in Indiana at Purdue University in those years where the disease was high. This is because this thing, it was just, this guy found it in a pond, or just next to a pond, right? He didn't literally fall, in a field of wheat, okay? So if it was going to happen, we kind of reason it's got to have a lot of the disease kicking about to be in high enough concentration that it's going to seep through the ground, presumably rain wash through or something, and make it into some mud, be picked up by the meteorite and be detected ages later. So basically we found out there were 2 years where the disease was highest. So we at this point really got in touch with Purdue University, and we asked them to look into the wording of this to say, hey, look, this is a really historically important thing to the university. They absolutely love this meteorite. You can imagine it's pretty much named after their town, named after Lafayette himself, of course. And I asked them to look into the wording to check if it would mean at that time international students, or it would literally mean black students, for example. And the library and archive team did a deep dive, and they did say that yes, it would just mean black students. And literally Well, sorry, and literally there was only, in 1919, there were only 3 black students, and in 1927, there was only 1 in the whole university. So this was a time in Midwestern USA where you can imagine, 1920s America, what it was like. But what is incredible is they do have their names. I'm not going to say them here because this paper has just been accepted. And some of them do, from what I've dug around, have living relatives. And we'd really like, when the paper goes out, I'd really like to go contact them. So that's what we're going to wait and do. But fingers crossed. So we've done a bit more deep diving as well to see if we could work out, okay, we've got 2 years where it was likely, this thing was likely to happen based on the disease. And it's possible because there were black students in both of those years at the university. So then we thought, was there a fireball in those years? Like, was there any reports of the public seeing this thing? Can we constrain it even more? So there were fireballs, meteorite falls that they heard or saw, mostly saw, recorded by the public in the Midwest in USA in both those years. In 1919, there was one on the night before Thanksgiving at about 8 o'clock. And it was in northern Indiana. And this is the mad thing. And if we have time later, I can show you, there is literally a map someone drew of all the, in this time, in 1919 as well, someone drew a map of all the people who'd observed it and what the weather was like and everything. Oh, it's just been amazing. I've done so much deep diving into all sorts. And it was in northern Indiana. However, it was like about 200 kilometers away from Lafayette, they think, which is probably too far unless their maths was really, really bad, which, to be fair, there was quite a lot of cloud around. But we've looked into it and we don't think it's viable based on what we know now. But, these things, as everyone, we know from Winchcombe, people thought this thing was falling in their, outside their house and it's hundreds of miles away. So it might really have just been people being totally mistaken. But for me, the thing that gets it is that a student was fishing at the time. And would you be fishing at 8 o'clock at night in November in Indiana where it's pretty cold? I don't know. So in 1927, there was also one in the Midwest, a fireball, but we know it dropped the Tilden meteorite, so we can rule that out. But the thing is, if the guy was fishing, it was probably a daytime fireball, so you might not have seen it anyway. So in terms of other things that kind of have built on this and helped us with kind of narrowing this thing down or helped us strengthen the case, is that we found other metabolites that are native to this state. So other compounds, basically, native to the state and kind of related to vomitoxin as well. So we found this thing called gibberellin A15, and it's basically produced, by a similar fungal disease as the fusarium head blight thing. It's literally got a similar name. If you looked at that plant disease thing, it's called Gibberella Z or something. So really similar, strengthens the case that this stuff does stick around in our samples. We found a bunch of these things called sesquiterpene lactones. You can tell I'm not a biochemist here, which are all really similar looking compounds produced by a particular species of plants. And 2 more of these in particular, which are produced by wild quinine. And this actually has, and it's a plant indigenous to Indiana, and it's still found really close to where the meteorite is said to have fallen. So this is this thing called tetraneurin E. And this is the plant, really quite pretty. And basically, there's a thing called the Indiana Plant Atlas. It's amazing. Again, who knew, right? I've sort of become who knows? Who knew these things existed? Accidental botany. Never in a million years when I did a Mars PhD did I think I'd be looking at like plant maps, but there we are. So this is the current distribution of this plant in wild in Indiana. And this is where that county, the county of Tippecanoe, is in relation to where you find this stuff now. So it's really close by, but quite possibly, humans are, we're pretty awful. It may well, it's pretty likely that it could have been closer back then, or maybe it's just as in more widely distributed, or maybe it says this thing fell to the north of the county. I'm not sure. So in terms of what we've done to kind of constrain it, well, 2 years, there are 2 years when this thing could have fallen based on the disease prevalence. We think in those records, and I've been back through them all, 1919 stands out by the most by miles, and then 1927 still had a lot. There were 3 black students in 1919 and only 1 in 1927, which is just, yeah, wild. What a time. And yeah, all these extra kind of plant-based things just really reinforced that it fell in a rural environment. So this story that this student found this thing while he was out fishing, in the countryside, the fact we've got bits of, metabolites from plant processes very much says, okay, well, that story is definitely plausible. And if that story is true, then we think we've narrowed it down to these 2 years, which is just wild. And I think it's fun anyway. But I mean, what does it all mean for Martian science or planetary science in general? I guess the big thing here is we're 100 years later and this stuff is still detectable. So it really shows how easily, and by the way, my samples were like 50 milligrams, not even that, 30 milligrams, I think. So tiny bits of Martian rock that have collected a few compounds after being on the ground for, sounds like really not long at all, because he just was fishing, it fell and he picked it up and he took it home. So bits of Mars get contaminated really easily and the stuff will hang around for a really long time. But clearly this technique, this sort of non-targeted metabolomics, LCMS, clearly it's a really useful way to be able to track that. But obviously when we do Mars samples to return in the future, obviously we don't want to be in the position where we're going to have pig vomiting disease on our bits of Mars. So we really want to be so careful because this stuff sticks around. But I guess another thing that's kind of come out of this is, forensic, planetary, meteoritics, whatever you want to call whatever it is I've done. I think it really harks back to what Ashley said this morning, is that meteorites have more than just a scientific importance. They are so exciting, and Winchcombe really showed that. They have this cultural thing, and I kind of feel like this story, particularly because it really does, I feel like the fact that this student was black and therefore that was why he was forgotten. Like they said, it was only a few years before in the paper, is probably why that student was forgotten. I think that carries a whole lot of extra weight here, and it means we really needed to get this story told. I don't think we'll ever know exactly who it was, or maybe someone else can constrain it further. So if anyone's got some samples of Lafayette and wants to keep looking for this thing or any other bits in there, then do. But I think it really shows the cultural importance and the kind of constant link between humans and meteorites in a way that's not just, hey, look, let's zap it with an SEM, which obviously is really important and cool anyway. And then finally, my main thing was just to say, like I mentioned, what we want to do once the paper is finally out, like it's just in all the editorial stuff at the moment. Plan is, we'd just really love to see if we can contact the families of those students. One of them actually had I think their daughter or like granddaughter was like a proper civil rights activist in the 60s. So I got very excited about that. And I think that person does have kids surviving now. So yeah, you can tell I went a bit wild, went down so many different rabbit holes with this. But maybe one of them actually heard that their great grandparent, whoever knows, I don't know how many generations it might be, but maybe there's a story in the family that they found a cool rock when they were fishing that fell in the pond. And hopefully we can tell them that, yes, it was this meteorite. And with that, I'll leave it. And any crazy questions you've got about how we did this or anything else you want to know, please ask. Thank you.
Well, thank you, Áine, for that fantastic talk. And yes, we've got you nice and big on screen again, which is great. We've got some time for questions. So does anyone have a question they'd like to ask Áine? We have one. Monica, first question. Obviously online as well. If anyone online has a question, please put your hand up.
Hi, Áine. Monica Grady, Open University. Great talk. Really enjoyed it. And I know you will have thought of this, but you said you've been in touch with people at Purdue in the archives and the library. Have you been in touch with people in the geology department there?
Oh, yeah.
Or?
They're on paper, yeah. So one of the planetary scientists is involved. They didn't actually have a geology department at the time. So back in the 1920s, 1930s, apparently it wasn't a proper department. That's one of the things. So Marissa Tremblay, I don't know if you know her, she used to be at Glasgow, but now she's a planetary lecturer over at Purdue. She's the one who's really kind of managed that side. We've also got a Purdue agricultural scientist involved as well, who's done all the kind of, could this have hung around? How would it have worked? That sort of side of things over there. So Marissa, yeah.
What I wanted to ask is, have you got any plans to go over to Purdue? Get yourself invited over there and, do a great big public lecture there.
Yeah.
Because, it's just like so interesting. And the other person to talk to is Tim McCoy at the Smithsonian, who actually has the massive Lafayette. Yeah, and it is truly beautiful. It's even more beautiful than Winchcombe, That's all I can say. But thanks again.
Thank you so much, Monica. And yeah, it's a good idea. I spoke to Marissa about maybe when the paper does get published, having a joint plan with Purdue about how we publicize it. I kind of want to do a podcast, like a true crime style podcast. Is that really good?
Yes. Yeah.
I feel like it lends itself to that.
You should absolutely get invited over to Purdue to give a big address. I think that it's a big part of the university history, so I think that's a fantastic idea. Matt, I think, was first at the back, and then Francis.
Oh, thanks, Matt Baum, Open University. Great talk, really interesting. This technique that you've done on this meteorite. I mean, I'm not a meteoricist. Is this a standard thing to do to all meteorites, or could this be a new avenue of looking for agricultural contamination across basically all the finds we found and get some kind of big database of, what is contaminated, how long it lasts? Because maybe there's older finds that don't have this thing, but are from a similar area.
Yeah, it's really interesting. Thanks, Matt. People do LCMS, but they generally target different, usually. So there's a team at Goddard in the States who do this LCMS as standard, but they tend to narrow in more carefully on things like amino acids. They basically do the opposite of what we do, most of what we've accidentally done, and look for what are the things that we think will be in there and rule out the contamination, and that's it. And there's somewhere we've said we have matched up NARCLA in particular with what those guys have found from the contamination perspective. So NARCLA's an example. It fell in Egypt, and there's bits in there that match up with the Nile. So it does work. It has been done a bit, but there's not been this kind of sort of contamination. Let's look at finds. And I totally agree. Personally, it's been so much fun, and it would be really cool for the ones we don't know the story of. I think the main thing would be convincing CFC that it's like sexy science, because I don't know, unless I can prove that this is I can have a big splash with paper, but it doesn't have the same origin of the solar system or whatever. It's just a public interest thing almost, isn't it?
Francis, I think, was next.
Oh yeah, sorry. Hi, Áine. This is Francis. Congratulations. You mentioned that it fell in a pond, and you were looking at the contemporary vegetation, and it didn't quite match up, but was nearby. I was just thinking ponds are quite good at preserving pollen. So are there any paleo pollen records that could tell you about the past distribution of crops or whatever it was?
Oh my gosh, that is such a good idea. Sorry, and a really good reason. So one of the things I tried to do, one of my many deep dives, was looking at really old maps. So I got in touch with, Tippecanoe County have their own historical organization, right? And I got in touch with them to try and see if they got any old maps of where the ponds were at the time. So I tried to constrain them with, well, if I can find out where the farms were, where there were ponds, maybe near the university, something like that. But oh my gosh, doing it from the paleo cores and the sediment, because it was just in the mud at the outside, would be an amazing idea. I had not thought of that. I just talked to people over there about just going over and collecting samples and just seeing if in a year where there's a lot of it, because it does still happen now, just seeing how far away you can get it. But there have been kind of papers talking about where you pick up the infestation from. But yeah, that's a great idea, Francis. Thank you. Maybe, yeah.
So I think Louisa at the back.
Hi, Áine, it's Louisa Preston, MSSL. This isn't really a question, it's more of a comment and just a thought that we were just gossiping about back here. Potentially don't rule out a date based on like a report. Because one thing we were thinking was, yes, a student probably wouldn't be fishing at 8 p.m, but they might not admit to whatever they might have been doing randomly out in a field at 8 p.m. So I was like, don't base your scientific answers on potentially that. So it's just a comment.
That is a very, yeah, you know what? I have not even thought about that. You're so right. Yeah.
Might help constrain some dates.
Yeah.
We have another one here.
Hi, Áine. This is Mukesh Bhatt at Birkbeck. To follow on from what's just said, maybe the student at the time was actually looking for his evening meal, so maybe he was fishing or poaching or something. But taking what was going on, you said that this is basically a wheat blight.
Yeah.
What in that case, given that it was found in a pond or in the field or whatever, does it tell you about the social conditions and what was happening at the time to the people who presumably survived on wheat or were trying to sell wheat or something?
Yeah, so it's interesting. The disease
that's a different direction to go in.
Yeah, it's interesting because I was looking at the toxicity of the thing, and it doesn't. The amount that humans can consume is a lot higher than what pigs can. So the reason they found out about the outbreak was literally because there's loads of pigs thrown up all over the States in 1990. And then they were like, oh, something must be going on. And then they inspected it. But yeah, you're absolutely right. It's socially, culturally, it shows that, you know, it is a big problem, and it's a big reason why they had to have these records, and they have this big department at Purdue that really focuses on this stuff. And very conveniently, that means we've got someone on the paper who is specialised in it.
I think there was another one. Someone, yeah.
I think that's going to be me. Hi, Áine, it's Ashley. This is like the anti-Winchcombe, isn't it? We have absolutely no idea when it landed and how it's been stored and everything. So it looks like, you know, if this is a relatively fresh fall, that it was contaminated really quickly. I mean, and I'm assuming you were looking at internal bits. You're not looking at stuff from the surface.
Yeah, it was. Yeah.
So
it was. I don't know for sure because it was a piece. It was a bit that someone else in my lab had used for rhenium osmium, and it was a leftover. He'd crushed it in Durham to do rhenium osmium, and he had leftover. This was basically the offcut from that.
Okay, so have you checked for blight in Durham?
Well, no.
It's a slightly mean question. Is should we be sceptical of reports of organic material in Martian meteorites if they can be contaminated?
Yeah, I mean, so it's a good point. I think that was why I made such a big point of, well, this disease doesn't happen in the UK, so it can't have come from here. It's like Norway and the Midwest in the US is kind of where it happened. So that was kind of the first thing. But I totally get you. Like, it does make you think, well, we really need a lot of evidence to show what's terrestrial and what's not. And I think the game changer will be when we're able to do, or we can sometimes, but very rarely do, like compound specific isotope ratios. So if we were able to look at the ratio of to the non-meteorite, non-isotope people here, but essentially different planets have different amounts of hydrogen proportions in them. And this technique can't yet look at one compound class, like look at this one, say look at vomitoxin, and they look at the compound ratio, which is the ratio between hydrogen and deuterium in there. But if we could, which is something we're trying to push the machine to do, but it's tricky, then that would tell you, right? Because your D2H would be your like obvious thing, right? If it's space-based or not. But then in terms of where it's actually come from on Earth, you're absolutely right. But I think that was where I said, well, we know it's near enough. It went straight from there into a draw. sort of like glacier things. And then near enough has been in meteorite collections ever since. So where would the most obvious source for this thing to come from, especially when it's got loads of other similar native Indiana plant-based stuff in there? Kind of stands to reason. Like it's, I don't know. The reviewers seem to be happy. So
sounds like our sample return, I think.
Yeah.
Do we have any other questions for Áine? In time for one more, I think.
Hello, Peter Forden, Open University. Just thinking about what Ashley said about the speed of contamination. Has anyone, I'm definitely not a meteoriticist question, has anyone done any sort of contamination studies of dropping some meteorites into mud and then picking them out and seeing how long it takes to do stuff? Right?
Not sure about that, but they definitely should. But I guess it would be, I don't know, Ashley, you could tell me, will the NHS say yes to that? Let's deliberately. But
Ashley's got those which can go for
You're gonna have to tell me what he said.
Yeah, so I'll just relay that. So Martin Suttle was just saying that Winchcombe almost gives you a kind of natural experiment because you got pieces that were picked up very quickly after the fall, and then pieces that were sat in a field for a bit longer, a week or so before being found. There could actually be an opportunity to investigate that.
So I have done the same technique with Winchcombe. I have actually just focused on the bits that were in common with the two samples, like because I've got one from the driveway and one from the field that came a week later. But yeah, the next step will be, and I've got all this data, so it's just plowing through it, will be, okay, how much more obviously terrestrial stuff, or most likely terrestrial stuff, is there in the one from the Rushbury farm than there is in the Wilcox driveway, especially because the Rushbury farm was literally in a sheep field compared to a driveway. Like, that's a very different environment. So you're absolutely right, Martin. And I just need to dig through that enormous spreadsheet some more. Maybe I need another lockdown to do another detective work, because I've got 11 weddings to go to, which is part of the reason why I had to do this remotely.
Well, I think that actually wraps it up really nicely. Let's hope we don't have any more lockdowns and your weddings go really, really well and you have a great time. But thank you so much again, Áine, and congratulations. So let's everyone say thanks again to the winner this year's Barrie Jones Award.
Thank you so much, everyone.
So that's it. Now, everyone who's going to the conference dinner, please make your way towards Kent's Hill. And Áine, thank you so much, and we'll see you again soon.
Have a great time, everyone. I wish I was there.
Thank you, Áine.
Cheers. Bye.
Recording is available.
Super. Thank you.